Hey everyone, in this video we are going to solve the equation on the screen right now, which is x squared equals 5x minus 9. Now, first thing you want to do is you want to realize that this equation falls under the umbrella of polynomial equations. Polynomial equations, a go-to method for solving them is, initially I would get it equal to 0 by applying basic algebra and simple arithmetic, get it equal to 0, and then from there you want to try to factor it, and then if you can factor it after you get it equal to 0, you will apply what we call the zero product property, which means you take each factor in the factored form and we set each of those factors equal to 0, because in order for a product to equal 0, this times this times this times this, any piece of that product is allowed to equal 0, because 0 times anything is 0, and that's how you'll find all the different answers. Another little tidbit to keep in mind is the exponent. The largest exponent in a polynomial equation is going to tell you the maximum number of answers, if you will. We'll get into that more later on down the line. But for right now, we could describe it like that. Now, those might be, in this case, 2 real answers, 2 imaginary answers, or we could have 1 real answer, which might be considered what we call a double root. So it's like that answer almost is the answer twice, but we'll elaborate in the future. So let's just dive right into this. So what we want to do first in a case like this is you want to get the equation equal to 0. So I have right now x squared equals 5x minus 9. And a lot of the time when people see one, let's just do a little comparison over here, okay? We're going to call this different because it is not the same. All right. And the different thing I'm going to write down is, say you have like x squared plus 5x minus 9 or something along those lines. If I have something like this and I don't have an equal sign, this is an expression. We cannot add something to the other side. There is no other side. All right. This is an expression. It's just one thing. There's no equal sign. You can't just stick an equal sign there because you feel like it. You can't just drop an equal sign if there already is an equal sign. In order for us to add 5x to both sides, subtract 5x from both sides, in order to do that, you have to have 2 sides, right? So you're not doing any of that here. The directions on a question like this might be factor, simplify, combine like terms, something along those lines. Evaluate the expression if x equals blank. You're not going to be asked to solve. Usually though, simplify. Here, if it's an equation, they're probably not going to be asked factor the equation. That's weird, you know? Like, you're going to be asked to solve the equation. And when we say solve, we mean for x. So that's our whole spiel. Let's get into it. If we want to get this equal to 0, I tend to focus on the leading term right away. The leading term is going to be the term with the biggest exponent, and I want that to be positive whenever possible, just to avoid any other headaches. So since x squared, so I'm just going to focus that a bit, since x squared is already positive where it is, I'm going to bring the 5x and the 9 to it instead of bringing the x squared over. I do that because usually when I'm reading work, students will mess up factoring or quadratic formula, whatever they're doing, when the x squared is negative, because I don't know, it makes a mess for people. So let's go ahead. I'm going to subtract 5x. Now, we do not have what we call, this is here a linear term. We do not have a linear term on the other side. We do have a quadratic term. They are not like terms. You cannot combine them. You cannot add or subtract them. Please stop doing that. This here is a constant term. Also, cannot be combined with those other things. So when I subtract 5x from both sides, on this side I have x squared minus 5x. They don't combine. Stop. Please stop doing that. Please stop. Then I can add 9 at the same time while I'm at it. Why not? Let's squeeze that in there. And that means That and that cancel. That is canceling. Canceling makes 0 with addition, subtraction, or adding opposites, whatever you want to call it. And that equals then 0. Now we said if we're going to solve this, right? We said this is an equation, right? If we're going to solve something like this, that means that you want to try to solve by factoring first. So if I wanted to try to factor this, if I kind of go down my list of factoring methods that we've gone over, factoring method 1, I consider to be check if you have a greatest common factor. And in this situation, we have no greatest common factor. Factoring method 2, I would jump into grouping. And this isn't really set up for grouping as is. We might use a combination of things with grouping, but right now that's not really the case. Factoring method 3 is the sum and or difference of two cubes. And even if you have something cubed in the problem or any perfect cube, which we don't, you can't use it unless it's just two things, really. Obviously, there's weird things in every situation. I'm just keeping it simple. You can't use that when you have like a trinomial. You're looking really more for a binomial, okay? So that's not looking like anything either. So this is out, this is out. Factoring method 4 for me is the, I'll abbreviate, difference of two squares, looks like dots. And again, I don't have a binomial. I don't have just two things, so that's out as well. The best option for me to try right now is going to be factoring method 5, which is the AC method with grouping. So the AC method is what allows us to split that middle term, and from there we'll do grouping because we'll have 4 terms. But if we tried this, A is 1 and C is 9. Okay, A is 1, B equals -5, and C equals 9. Squish it over there. So A times C is how you would start. 1 times 9 is 9. You would look for a pair of factors that multiplies to give you 9. Don't try to be a hero. Go in order. Once you got everybody, you check your B value and you look, can I make this B value of -5 with any of these pairs of numbers that I use to multiply for AC, but can I add or subtract them to make -5? The answer is no. What does that tell me? This is not factorable. A second way to check if something's factorable, this is, you're getting a whole deep dive right now, everyone, so you're welcome, is if you check the value of B squared minus 4AC. You might recognize that as being a piece of the quadratic formula, and you'd be right. But if B squared minus 4AC is equal to a perfect square, so this is me just drawing a square to not have to write the word. If B squared minus 4AC equals a perfect square, that means it is indeed factorable and you're messing up. If B squared minus 4AC is anything but a perfect square, it's not factorable. And you're already done with part of the quadratic formula anyway, so you might as well just finish, right? So let's check to make sure. B squared, always put parentheses around the B, especially when it's negative. -5 squared, again, parentheses are your pal, minus 4. And I would do the A times C first. Watch your positive negative rule. Some of you guys were doofing off a little bit with that. So 1 times 9, which is already the AC we did here anyway, right, is 9. Now, -5 squared, the B squared will always be positive, guys. If you're getting something negative when you do B squared, you're just not doing it right and you haven't been paying attention, okay? B squared, I promise you, will always be positive. Whether it's a positive or a negative, it's in parentheses, and anything times itself, negative times negative, positive times positive, I promise 1,000 times over is positive. So that right there is 25 minus 4 times 9 is 36. Now immediately, oh, sorry, run out of room, sorry. Immediately, guys, alarm, alarm, alarm. Definitely not a perfect square because it's negative. No negative number is a perfect square. However, let's keep going so we could finish this up nicely. It's -11, so it's not factorable, which means you have to solve with quadratic formula. You have to. Now, what is the quadratic formula? X equals -b plus minus the square root. If you need to look at this every time you're using it, you need to step it up, okay? You're probably in high school. You can do this. Just memorize it. You memorized your name. You memorized lots of other things. Do it. Just do it. Just memorize it. Stop having to look at it. You don't know it, how to use it that well if you don't know what it is. Come on, let's do it. B squared minus 4ac all over 2a. Now this over, all over, does not cross over to the other side of the equal sign. The square root should cover the entirety of the b squared minus 4ac. So it does matter how you set this up. Now we fill in x equals negative b. If b is already negative, which it is, negative means opposite, so you make it positive. We got this. Plus and minus, this is two equations in one, folks. B squared minus 4ac, I already did it. It's negative 11. Just jump right to it. All over 2 times a, so 2 times 1, which is 2. Now really, for this, we only have a teeny bit to go. When we have a negative under a radical, negative or negative 1, that is known as the imaginary unit I. Some of you at this step, depending on your class, you might just write down no real solution. If you're going to pick it up just a smidge, the negative on the inside can come on out as an I right in front of the radical after the plus minus sign. It's just like bumped in front of that square root, okay? 5 plus minus I radical 11. Now I try to put like my hat and shoes on my 11, on my ones rather, when I'm dealing with I, and a heavy dot on my I. All over 2. If the 11 could be broken down like a 12, 2 times 2 times 3, I would try to simplify the radical. 11's prime, not going anywhere with that. So we're done. So here we have two imaginary or non-real solutions. Two imaginary solutions. So if you put no real solution, that's great, okay? Depending on what your teacher expects from you, you got to do what you're supposed to do. All right, so that's the end of that. If you got to maybe this step, you might be allowed to just write no real solution. You know, we figure it out from there. But we do have two solutions. They happen to be two imaginary solutions. The largest power in the problem was 2, and that is an indicator of how many solutions that we have. So hope you understand. I hope you feel smart. I hope you got it right without me. Thumbs up if you did, thumbs down if you hate it, and click through for the next example. Have a great day. Adios.